Okay, we have another repair. It's a Sunday repair. Uh, so our model number is 82141. It's a 16 inches. Light is put the light on. It's 21, 82141. It's a 16 inches, and the description it's no power. So let's see what we have. As you guys know, the first thing we want to do is we want to take out the back cover. Can I have the back screws, please? The back screw. Thank you. So, like I usually say, before you connect your charger to your device that you're working on, make sure you confirm that it is safe to do so. So first thing first, you want to open the back cover of the device so you can have an idea of what you're dealing with. Okay, this has been attempted. Yeah, this has definitely been attempted. Okay, so say we have missing screw, we have mismatched, we have worn out screws here, and we have a flux around this section here. So this tells us that there has been a previous repair attempt. Let's this. We're not sure exactly what the repair was. So we have this screw missing, that screw missing. So let us confirm the state of the board. Just first we disconnect the battery, and then we want to see. So let's measure for short. Meter is in continuity mode. Black hole to ground, and then let's check our fuse. Okay, we have a short on our PPBUS. Okay, so just gonna let's open up this board view. The board number is 80-01700. That's the board number. So this is our board. We can measure for PPBUS here, the two fuses. So we just checked now, we have a short on our PPBUS. So the reason why I had to go straight ahead to see if we have a short on our PPBUS, it's a common failure on the 16 inches. You either have a short or you have a PPDC in issue. You probably will also have an issue in the SSD rail, which will also translate into a short on your PPBUS rail. And the fact that it's been worked on here, the fact that I see that the job was there's been a previous worked on here, it basically tells me that definitely there might be some kind of a short on the board. So which is why we had to check for PPBUS short. And as you guys can see, we have a PPBUS short which I was able to measure on F7000. So I had to measure the PPBUS short here. Now, the type of short that we found, it's just black probe to ground and then red probe. So you see this, and by the way, you see the battery is disconnected. So this type of short, we have in 00331. So this is pretty much telling us that we do not have So what this means is this is more like an extension short. So what that means is the short is not represented in our PPBUS, because if it was in our PPBUS, I would get a different reading. The fact that I am getting uh, um, I'm not getting a complete shot to ground, it tells me that an extension or a rail that is connected to my PP bus is what my issue is. So I kind of feel like the issue might be from the SSD rail, which is the NAND. So what I want to do now is I want to take out the logic board and confirm if that's the case. So also the fact that, like I said, the fact that there's been a previous work around the section, it could also be that one of the NAND might be fried. It's really a common issue with the 16 inches to have a fried NAND. So usually what happens is um, so the PP bus voltage is what feeds the NAND on the board. So how that works is so there is a buck converter that basically takes the 12 volt, 12.6 volt, the PP bus voltage, and then split it into 2.5 volt and 0.9 volt for the NAND chip. So usually what happens is the buck converter dies, and then it sends straight the 12 or the PP bus voltage without having to break it down to 2.5 or to smaller voltage into the NAND. And then obviously the NAND cannot handle such high voltage, and then as a result the NAND dies. Now what is the fix to repair like that? Now the repair, I mean the fix to that is to obviously replace the NAND. So you replace the bottom data itself, and then you also replace the NANDs. So it's a tricky repair, because when that happens, you lose your data. You're not getting your data back. Yes, you will get a functioning machine again, but your data will be gone. So, which also brings me to the idea of making sure you have a backup of your valuable data on your machine. I know it sounds very easy to say, but it's not that practical. People are not very much conscious of having to back up their data. I mean, I can say that for myself as well. I mean, I don't. I mean, I do have. I mean, I don't. Also, myself, I don't have like a. I don't go to like a regular backup system for my machine. So, pretty much. But I would say it is really good if you can back up your important data. Just to, another option you can opt into, it's the cloud storage. Just to be safe, in case something happens, you are safe. You get a functioning machine, but then you don't have to also, I mean, you don't want to lose uh, so much of work, especially because some people, they have really valuable data. So try as much as you can to create a form of a backup system for your device. Just prepare for the worst. Anything can happen. So when it does happen, you can actually have a safe landing, somewhere to start, or not completely stranded because you don't have your data. Okay, so our logic board is out. Now we want to kind of get an idea of exactly why we have our PP board short. So first thing first, we want to find out what work was done. Just move this. Okay, so just like I feared, so this is the section. Um, I'm just going to show you guys. Uh, U9580 does the switching. So U9580 takes your PPBUS voltage and then it switches it, and then it outputs 2.5 volt. And so you have 2.5 volt amongst what it outputs: 2.5 volt, 2.5 volt, 2.5 volt, 2.5 volt, 2.5 volt, 2.5 volt. So when the chip fails, when U9580 fails, what happens is it sends two a PPBus voltage straight to the NAND, and then you don't have a problem. So instead of having to send 2.5 volts to the NAND, it sends PPBus straight to the NAND. So also the section that was worked on. So this is the section that was worked on, which is the section for for the NAND voltage output to the NAND. So what we want to do now, okay, I see here they also try to inject voltage onto the board to see which section of the board is affected. So what we want to do is we want to find out if our buck converter is affected or the NANDs are affected. But definitely, so one of the ways we can easily confirm if our short is contained in our PPBus or on the section of our NAND is to remove a current resistor on that line, which is R5620. So R5620, with that removed, we basically have divided the bridge between the PPBus and the section of the NAND. So what you want to do first is to remove R. We want to remove R5620 to then see where our short is contained. Okay, the current resistor is out. Now let's measure on our PV bus again and see if we have a short. Ammeter, it's set to continuity mode. Black Pro is going to go to ground on our board, and then our red will go to, okay. So that is our fuse, and then as you guys can see, that is OL. We no longer have a short on our PP bus. So the first time, the fact that we didn't get 0 0 complete short to ground on our PP bus rail when we were measuring, it tells us that is what it tells me is that my short is not completely contained in my PP bus. It's basically a bridge rail or a rail that is connected to my PP bus that is affected, which then basically is represented or translated on our PP bus. So now that we have removed R5620, we see that the short is no longer there. So I'm just going to go back, black probe to ground, and then our red probe on our fuse, and then we see we have OL. We no longer have a short on our PP bus. So the next thing we want to do, let's see. The next thing we want to do now is we want to see if our short is contained in the circuitry or in the inductors, obviously not the inductor. We want to confirm if our short is either in any of the caps here, which it almost never is the case. To confirm if it's the buck converter, it's almost never the case. Most likely you're having an issue with the NAND. Let's see. Yeah, but let's see if that is the case. Let's see if we have an issue with the NAND. So what we want to do is so U9580. So we want to let's Let's measure by the inductors. See what we get. Okay, let us remove. Let's remove the inductors and see what side is the short. As you guys know, your inductors, they are more like a wire. So whatever you find on one side, you definitely find on the other side. So what we want to do now is we want to remove the inductors on the output line to see where our short is contained. And the guys have actually worked on this before. They pretty much did the same thing. They obviously took out, because I can see the inductors were taken out. They took out the inductors, and then obviously they checked where the short is represented, and then they had to inject voltage as well. But in a repair like this, it's pretty much straightforward in terms of getting to 9 out of 10. The issues are going to be the 9 out of 10. But let's see, where is our short contained? Okay, and then the other side, like I said, our short is contained on this side of it. So yeah, so pin one obviously is going to be from U95 80. So pin one of L9580, yeah, will come from our U9580. Now pin two is what is going to be present. The pin is going to be present on our NAND. So this is 9 out of 10. The issue is going to be on 9 out of 10. So um, for this repair to be complete, the one of so usually one of the NANDs, one or two of the NANDs go faulty, but then what you can easily do, you can just replace the entire four, which is 1, 2, 34, and then you'll be good to go. Um, uh, let's see. The struggle is we do not have the NAND in stock. That's the struggle. Um, okay. And this is really my issue with the 16 inches. The NAND just die, and yeah. If I were to advise somebody to buy a device, I wouldn't. I don't know. I wouldn't really recommend the 16 inches. You can get a new one, the 2019 versions, but after like a year or two, chances of your NAND dying out are very high. Let's see. Uh, okay, okay. Let's see. Let's let's just inject voltage. Even though even though I mean it's pretty much confirmed almost that the issue is going to be one of the NANDs or one or two of the NANDs faulty. But just so just for the yeah, so to confirm that indeed that is the case, let's just basically inject voltage into the line. So the concept of injecting voltage into the line is so usually what happens is so I'll go back. So now look at this is an output of 2.5 volt line, and the output is shorted out. So the concept is you attach a wire here, and then you attach another wire to ground. Now you gently inject voltage onto this line. So the idea is whatever component on the line, on this line that is shorted, it's going to become warm as you gradually inject voltage. Now, when you're doing this type of troubleshooting, you have to be careful in terms of your power regulation. You do not want to. So, for example, this is a 2.5 volt line. So you be very careful in that. You don't want to put in too much voltage because you don't want to damage the components that are on that line. So you try as much as you can to contain your voltage injection between 2.5 to, at least you still can go to 2.7 to around about 3 volt. But beyond that, I wouldn't really recommend it. So when you're doing this, you have to be really, really careful when you're injecting voltage, especially when you have an extension, components like your NAND chip or your CPU on the line. You have to be really careful when you're injecting voltage because this will give you more headache. If you don't have such components to worry about, then you don't have to worry. You can put in as much voltage onto the board. But in a case situation like this one, where you have your lines that are on the line, that I'm pretty much sure that the issue is going to be the nine, one of the nine. But you don't know until you confirm. So we will be very careful in the amount of voltage that we put on the line. So what we have done now is we have one wire to ground, and then another wire connected to the 2.5 volt line. So what we now want to do is we want to gently uh, basically we want to gently inject voltage onto the line and see what gets warm. Okay. Just going to confirm something before we inject voltage into the line. Okay, so let's okay, let's inject voltage into the line and see what gets warm. This is okay. This is a little bit strange. Uh, okay, let's see. Not entirely. Let's see what is getting. Yeah. Hmm. So this is getting warm. This, yeah, it's getting not actually warm. It's super hot. Okay, this is fine. This is fine. This is fine-ish. But this, yeah, that is super hot. So I'm just going to show you guys that that is boiling hot. So I'm going to add a bit of flux to it, and then you can see how it reacts. I don't know if you guys can see. Yeah, but they say it melts immediately. That's super hot. So this land here is because of our issue. This one. Yeah. So, mm, okay, let's desolder that. So for this repair, we need to replace the entire. We just replace the entire four. Yeah, just replace the entire four. But the challenge is we do not at the moment we do not have the nine in stock. So I need to order those. So this is pretty much going to be a pending repair because we do not have the nine in stock. So I'm just going to put back the components we took off. Uh, I had to grab another current resistor. The one that I took off seemed to have flew off my desk, so I had to get another one. Okay, so that's it. So this is gonna go into pending repair. So what we need to get the NAND chip in, and then we can obviously complete the repair. So for now, this is gonna be yeah. So it's let's see that 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 that. Okay. See this. Hmm. So, pretty much. Um, so you see, we have one, two, three, four, five, six. This is not populated. That is not populated. So obviously, depending on the size of the NAND, that will determine how many you have on the board. So the one that seemed to be affected is just this, just one of it. Um, We will, however, have to order in replacements. Because without the replacements, there's nothing we can do on this board. So this board, it's really not going to work until we get a replacement, a NAND replacement for it. So this is going to go on a pending until we get a replacement for the NAND. Okay, guys, that is going to be the end of this repair-ish. This wasn't really a repair, but that's going to be the end of it. And yeah, I will see you guys in the next one. Okay, thank you guys. See you in the next one.